All right, intermediate algebra students, we're working on module 2, homework 6, and it's about polynomials. All right, so when we're talking about polynomials, there's a couple things about polynomials that we are concerned with, and one being is the degree power. Degree powers are not related to the coefficients, but always to the variable value, and then those are the exponents of the variables. And so in this case right here, obviously we don't care about the 2 because that's the coefficient, but we care about this degree power right here that represents that, that variable. So the degree power is 8, and that's the answer to that. But when you have a constant is like maybe 6, 4, 1/2, I mean, things like that. The variable is actually still there, but raised to the 0 power. And we have um, that power property, the zero power property that we talked about the other day, or in the last lesson. So that's 0 for that degree. Now, when we look at x to the 9th, then x to the 9, you can see where this is going. It's pretty straightforward. So I'm going to speed up a little bit. This is 6. And then when you're talking about an entire polynomial that's like a 4-term polynomial, not a monomial, we're looking at the one with the highest degree. Well, 9 is higher than 8, as well as 0 and 6. So 9 is our degree power. So we're looking for the highest degree power. So it's very simple. Just look for the highest number of the exponents, the power. So we don't really care about this. All right. So all we're looking at is this. So pretty simple. All right. So that's the answer to that. Now I'm going to go through this quickly. Question number 2 is going to be 6. It's obviously right there, 6. Not because of the coefficient front, it's because of the exponential power. 7 is the answer for this one. 4 is the answer for this one. 0 is the answer for this one. And 7 is the answer for this one. You can see how this goes very, very quick. You should have been able to keep up with me if you're doing your homework with this video or on time with me class. Now, when we're looking for the first term, all right, for the degree power, we're looking for the highest power, so that's going to be what, 4? And the coefficient of that, hold on, first, oh, well, they're given the form between these terms. Okay, so what they're asking for is not the highest power, they're asking for the terms, this is 1, 2, 3, 4, 5 terms. So the first term is this one, so they're going to call it out as 3, and the coefficient of that is -2. All right. Right. It says the first, right. So this is the first, not the leading, right. That's great interpretation. So second term is the degree power is going to be 0. And then, of course, the coefficient is going to be 3. Third term is 1. And then -3 for that. And then we have fourth term is going to be negative, excuse me, not negative, but 2. And it's going to be -7. The fifth term is 4 to 3 power and leading coefficient 5. All right. So make sure that you put the polynomial in descending order to understand the terms leading coefficient. That's what I think it was Ryan. Yeah, Ryan did that. All right. Yeah, when we talk about the leading coefficient, we want to make sure we put it in descending order first. So that's why the coefficient is going to be the 5 right here. And then what degree is the leading power is 4. And then what is the degree of the polynomial is going to be the highest degree, and that's 4. All right, so that's how that works. So yeah, you got to be careful with how you read it. Most of the time, they don't give you questions like this as much as they want to make sure that you ask for the leading coefficient. So which of the following are polynomials? Now, polynomials can't use division as far as when I say division, for the first one right there. You can't have a variable in the denominator. If we were to clear the out of the denominator, we would have also x the negative first. So you can't have negative values for exponents for that as well. So this one's definitely not a polynomial. All right, and this one's not for that same matter. Same idea that I just gave here. Okay. Now this one is a polynomial. This one is a polynomial. And this one, when we're talking about this is going to have x to the, x to the 1/2 power. All right, x to the 1/2 power. Now, when we're looking at the answer, all right, we know that we want our degree powers to be either positive, all right, positive, and they want to be whole numbers. So when we're talking about degree powers, so not one half for this. So this one's out for that reason. So we're looking for the power value, all right, to integers that are positive. All right, so now when we're talking about simplifying expressions and adding and subtraction of polynomials, we're looking at combining like terms. Now, whenever you have a negative sign in front of a degree or a grouping like this is, we want to go ahead and switch it from subtraction to addition, and then switch the sign to second grouping. So we have this. All right, so what did I do? I just took the negative sign, which is subtraction, changed it to addition, switched the sign to the second grouping. All right, and then that leaves me with then just adding my like terms, which these are like each other because they have both y squared. Add these together because they both have y, and then add these together because they're constant. So now -6 added to 7 gives me y squared. -4 added to -8 gives me -12y. And then 5 added to -6 gives me -1. And so it is, that's what we are left with. All right, so we're just combining like terms. Now, when we look at the next one, we have -x squared minus 8x plus 7. And then we have minus, but we're going to change that minus to its addition. Change the sign to the second grouping. All right. Now, when I go ahead and do this, all right, I'm combining like terms. I'm going to combine this to this, and that's going to give me -11 x squared. And then I have -8 added to 2x gives me -6x. And then I have no other constant to add 7 to, so I'm just going to put plus 7. And there's our answer. All right. All right. So that, what did I make a transcription here? I did do a transcription error. Geez, I made a transcription error. I was writing it too quick. I love checking my answer for that. See this plus sign? When I went ahead and changed the sign to the 10x squared, it should have been -2x. I didn't distribute my negative sign to both terms. It happens. So then this is good. I changed my answer. So be careful. That happens. Even to somebody who's trained at this stuff, who's doing this all the time, still happens. So that's why it's always good to look over answers and double check. But the concept is bring our like terms together. All right. Now, when it comes down to fractions, I know a lot of you are like, whoa, simplify the expression by combining like terms. All right, so we're going to go ahead and do that. Now, notice how they don't have parentheses on this. They're really trying to see if you just go ahead and combine the terms that have the same degree power. So we're going to have this. All right. Now, these two look like each other. So when I add them together, I mean, sometimes you can use calculators. Now, I don't want to encourage, lack of understanding how fractions work, but I'll do it both ways. But when you're dealing with this, um, doing this, I can take 110. I can take 110, and then I can go ahead and I can subtract 1/5 from it. So minus, hit alpha, this key, enter 1 over 5, and then I can go ahead and do this. Okay? So it's negative 1/10. That might be a little hard to read with this video, but the way you do that, again, you go ahead and do this. It's 1/10 minus, and it's going to actually be 2 over 10. That's what 1/5 becomes to get the same denominator. So then you go ahead and add these together, and that's going to give you 1 added to negative 2 is going to be negative 1 over 10 x to the 4th. Now bring this together with this. These have the same denominator. All right, so we're good with that. So we're going to go ahead and add negative 1 to negative 5 and get negative 6 x. Excuse me, negative 6 over 7 x squared. And then we're going to go ahead and then combine these two terms together. So 5 is understood to be 5, or excuse me, it's 45 over 9 added to 1 over 9 to get the common denominator. 45 divided by 9 is in fact 5. So 45 divided over 9 plus 1 is 46 over 9. All right, and then it asks, simplify the expression by finite terms, leave coefficients as reduced fractions. All right, so then we go ahead and give this right here, okay, making sure 3 can't go into this. Okay, so it should be the answer that we're looking for. All right, so here we have it, double checking my work. It's like I said, I make mistakes as well as you do, right? I gotta make sure it looks good. And I'll explain to you if I did make a mistake, that is in fact the answer. It's always good to check answers. And then transcription errors are avoided or conducted. Now, I'm going to go ahead and do this more mentally than I am going to do anything else. Now, I'm not going to write it all down for this next question. So you take 8 and add it to 5, all right? And you get 13 x to the third. And then you take the 7, that's right here, the 7, add that to 3, because they're combined like terms, then I'm going to get 10 x squared. And then I'm going to go ahead and get negative 7x added to negative 6x. It's going to give us negative 13x. And then I'm going to add 9 to negative 7 and get positive 2. So we can go ahead and identify our answer pretty quickly. We'll just do it next year. That's the answer we're looking for. Now, for primitive, question number 9. All right, it's adding all our sides together. So we're adding negative x squared plus 7x, adding that to 8x plus 5, and adding that to 2x squared plus 4. Now what we're doing, of course, when we're doing this, is just adding our like terms together still. So add this to this, and that gives us x squared, because 1, negative 1 added to positive 2 is 1. Add 7 to 8, and get 15 x's. And then adding 5 to 4, we get 9. And there's our answer that we're looking for. Of course, it's in inches. And we're going ahead and seeing that we're going to distribute the negative to both terms, and we're not going to make that same mistake. I mean, it's okay to make mistakes, but you constantly making the same mistake, that's not good. So I'm going to change that to a plus sign, switch the sign to 4x, and switch the sign to the -2 and make it become +2. And now combine like terms of -12x plus 5. All right, that'll be our answer there. And now doing this like the other one, I'm going to kind of just make sure I'm going to add it mentally with you. See, this is negative x to the third added to -5x to the third. That gives me -6x to the third. Now, looking for the next degree power will be squared. So I have a -2x added to a +7x, because that negative changes that to a positive. So it's +7x. So x squared, that is. So -2 plus 7 is +5x squared. All right. And then, of course, I then have a 4x and a -3x. That gives me +x. And then the next is a constant, a number. So that's 3 plus 1 is 4 plus 8 because it's double negative. So 4 plus 8 is 12. And that's my answer over there. All right? So look at it. I'm making less errors the less I write. Not that I think that all of you can do that. It is just my better practice is not to write so much because I don't make transcription errors. But everybody has to find their own niche. All right. Now, when I look at this, all right, I'm seeing I have several x or w's to the third powers. So I'm going to go ahead and look at -7 plus 7 is 0. So that's going to give me no more w3s right here. And then I have a w3 over here. So I'm going to put 2w to the third. And then I'm going to go ahead and look for the w to the second power. All right, so I have -9w squared. And then I have a -3w squared. So -9 plus -3 is -12w squared. And then I have 3w here plus 1w. That's going to give me 4w's. 4w's minus 10w's is going to give me -6w's. And then I have 1 plus 9 is 10 plus 10 is 20. And let's see if I got the right answer. That is correct, that's correct, that's correct, that's correct. So that's all good. All right, that's the right answer. So I just demonstrated twice to you that even as complicated as it was better for me personally to just do it mentally than it was for me doing a transcription error earlier where I made a mistake here, if you remember, okay? Which is easy to do, okay? So this can happen. All right, that concludes this homework. So we can on to the next.